So here we are at problem number 1 from the limits worksheet. We're asked using the graph of the function f of x to answer each of the following questions and to use infinity, negative infinity, or dne wherever they're appropriate. Now if we look at A, it's looking for f of 0. Well, if we look at f of 0, in other words, we're plugging in 0. Oops, let's get the marker. We're plugging in 0 for x. Well, when we look at this value 0 for x, we see that this guy's going down toward like negative infinity, and that on this side we see that it's approaching some hole. So because it's not really a definitive point, this guy ends up coming out to be dne, does not exist. For f of 2, we see that it has a y value of 0 when you plug in 2 for that particular x value. So it looks like it just, again, comes out to be 0. For f of 3, well, we see that there's a point here and a point here and a solid point there. These guys were holes, I should say, not really points. But because we have this specific y value, again, at 3 for our y value, we end up then with that following answer being 3. Again, just because there is a solid point there. For D, it's asking the limit as x approaches 0 from the left of this function. So in other words, we're moving away from, okay, well, what happens when you plug in this specific x value? You know, what is the y value? Instead, we're talking about limits. Now, the limit as x approaches 0, this means from the left, if it has that negative. Well, here is 0. We are approaching 0 from the left, so we are on the left side of 0 and we're approaching it, and we can see that it's going down to negative infinity. Now, when it's saying, for E, when it's saying that the limit as x approaches 0, just 0, it doesn't say left or right or negative or positive of this function, it's implying, okay, well, what is it on both sides? Because it's not saying left or right or negative or positive. What is it from the left side as it approaches it from the left side, and what is it as it approaches from the right side? Well, we can see that on the left side, we said a moment ago, it was going down to negative infinity. But on the right side, as you approach 0 from the right, it's approaching what looks to be a value 2. But because they're not ending up at the same spot, this would actually So that would be the answer for E. Now looking at F, what is the limit as x approaches 3 from the right? I'm actually going to clear some board space up. So what is the limit as x approaches 3 from the right side? Well, we can see that we are on the right, and we are approaching 3, that x value 3, and it looks like it comes out to be the value 2. Again, you're not actually plugging 3 into the function like we did with C. You're taking the limit as x approaches 3 from the right. Okay? So that's why you actually can end up with that actual value, that limit. For G, we're talking about, well, what is the limit as x approaches 3 from both the left and the right? So it has to satisfy both for this particular function. Well, if you're approaching the limit as x approaches 3 from the left, we see that it looks to be 1. But if you're approaching 3 from the right, again, a moment ago we said that it was 2. And now because these guys do not match up, this would not exist. They have to match both on the left side and the right side in order for that limit to exist. Finally, for H, what is the limit as x approaches negative infinity of this specific function? Well, if you were to go out for your x values towards negative infinity, we can see that it's kind of approaching that horizontal asymptote of 1. So that would be our final answer. So it looks like for H we end up with, oops, not negative 1, we have 1. So that would be it. And again, that is problem number 1 from the limits worksheet for the summer packet.